guys, welcome back to today's video, and today we will be doing what is a hybridization, shape, bond angle, bond length in the case of NH3, which is ammonia, right? First I'll use the shortcut and then I'll go to the lengthy procedure to find out the hybridization. So shortcut, you remember, steric number half, number of valence electrons of nitrogen 5 plus number of atoms attached by single bond 3. Answer comes out to be 4. As soon as you see the number 4, remember I told you hybridization is sp3, 1s and 3p will be there. So sp3. Now we have to talk about how many bonds and how many lone pairs will be there. So out of 4, 3 bonds will be formed and 4 minus 3 will be 1. So 1 will be the lone pair, right? This we already did in so many videos. So what should be the shape? It was supposed to be something like this. But out of 4 bonds, 1 has to be lone pair. So this remove and this hydrogen, hydrogen, hydrogen. And I remember telling you the shortcut also that this will repel the hydrogens. So the bond angle comes out to be 107 degrees. Right? This was the entire shortcut we had discussed. Now we will study how actually ammonia is this kind of shape. Okay? Let's get started with the same procedure. First of all, you know that nitrogen is forming 3 sigma bonds we just saw in the structure, right? So I will write nitrogen, 1s2, 2s2, 2p3, okay? This will not take part. We have 2s2, 2p3. See, I can explain this question in like 2 minutes. Video will be done, but you will not be able to answer the questions related to the intrinsic details about ammonia if the question comes in JEE and NEET. So I'm talking about all the detailed possible theory behind ammonia so that you may be writing whichever exam, the toughest or the easiest one, you should be clear with the concept, right? Now what I used to say that nitrogen has to form 3 bonds with hydrogen. So nitrogen needs 3 unpaired electrons. Right? This is what I used to say in my previous video. And then we used to look here and see, are we having 3 unpaired electrons? And in this particular case, yes, we do have these 3 unpaired electrons. Right? That means this should not combine with S because they are already available. There is no need of excitation. Right? So first thing that we understood from here, that no excitation is required. So till now, if you had been thinking that excitation of electron is a part of hybridization, take a minute, think again, and now I am telling you that excitation of electron has got nothing to do with hybridization. We just do the excitation of electrons so as to get the required number of unpaired electrons. Here, we already have required number of unpaired electrons, so we don't need to do the excitation. Okay, so clear, point number 1 should be clear that excitation is not a part of hybridization. Understood? Now let's go further. We have 3 p orbitals. All of them are like same shape, same size, same energy because they are belonging to 2p. So can't I say that this is z-axis? Let's say this is x-axis. So this is 2px orbital with 1 electron. Let us call 2px. 2py, 2pz. 2pz is also having 1 electron and 2py is also having 1 electron. Our problem is solved. We needed all the 3 things to be of the same shape and size, and we do have 2px, 2py, 2pz of same shape and size. Right? Now can I call 3 hydrogens to come and combine? If 3 hydrogens are coming, this bond will be PS bond, this bond will be PS, even this will be PS. So the 3 bonds in the case of nitrogen, according to our theory, should be, okay, by the way, don't get confused, this I was trying to draw like this. So the 3 bonds were supposed to be at an angle of 90 degree. There is no need of hybridization. Right? What is wrong in this theory? Why can't I say all the 3 angles are at 90 degree, everything is stable? Just think, I just gave you the hint in the last video if you had clearly listened to the video when I was explaining methane, CH4. Remember I told you that the 90-degree angle is not at all stable. When two bonds will be at 90 degree to each other, this electron cloud will repel this and this electron cloud so largely that because of the repulsions, the molecule becomes unstable. So, although there might not be any hybridization, but if hybridization is not occurring, the 3p orbitals will form the bonds at 90 degree, which is maha unstable thing which we do not want at all. So if this complete thing was wrong, what other thing should be done? Now see, I will just go from the beginning again. This is 2s2, 2p3. Am I right? Nitrogen needs to form how many bonds? 3 sigma bonds. And we do have three unpaired electrons, right? Cool. We don't need to do excitation. Now, if we do not need to do excitation, let's quickly simply think about what if it undergoes hybridization. Let's see. Let me combine all of them. So this is 100% S and these will be together 300% P. So when I mix 3 orbitals, I will be getting, when I'm mixing 4 orbitals, I will be getting 4 new hybrid orbitals, right? So this is again sp3 hybridization. The percentage S in each will be 25% and the percentage P in each will be 75%. I hope this much is clear, right? Now the second fact we are trying to understand from this particular example is, this is not necessary that the atomic orbitals which undergo hybridization have to be unpaired electrons. No. Even if we have a fully paired electron in the atomic orbital, that is equally eligible for undergoing hybridization. Okay. So how many number of electrons are there in the orbital has got nothing to do with hybridization. So here we learned two things. First, excitation has got nothing to do with hybridization. Second, whether the electron is paired or unpaired or empty, that has got nothing to do with hybridization. But this must be clear. 1, 2, 3, 4, 5 electrons are there. So I have to fill all of them with 5 electrons. Like total should be 5. So I'll fill 2 here. 1, 1, 1, 1, 2, 3, 4, 5. Done? Understood? So what is our next step? Now I have to arrange these 4 orbitals in such a way that they are maximum away from each other. You remember, right? Last video I told you how 4 orbitals could be arranged. We discussed that the 4 orbitals could be arranged in the form of a tetrahedral, right? But be careful now. How many hydrogens we have? 3. So let us call all the 3 hydrogens. They are coming and they are forming bonds. Okay. Now the problem is, we are still having one orbital with 2 paired electrons where no hydrogen is coming, right? Because this is already filled, no hydrogen can come. And we do not have 4th hydrogen, we just were having 3 hydrogens, right? Now listen, these 2 electrons which are taking part in the bond formation, I will write them like this. And these electrons are said to be the bond pair electrons. Fine. So the electrons, the 2 electrons which are taking part in bond formation are said to be bond pair of electrons. But this pair of electron which is just lying there, which is not taking part in bond formation, is said to be the lone pair of electrons. Understood? So these are bond pairs, bond pairs, bond pairs, and these are lone pair of electrons. Now let's try to understand one example. Let us say this is, okay, I'll tell you one situation. Let's say this is my mom and this is my dad and this is me. I'm like very cute and this is me, okay? So suppose I feel like eating pizza and my mom and dad, both of them are there at my home. I say, Papa, please can you order pizza? I'm feeling hungry. My mom, who is not even standing close to us, she'll just shout like anything. Why are you ordering pizza? I cooked this much, blah, 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 blah. So she started like this, right? This is obvious, no? This must be happening at your place also. That means when I'm under the influence of two parents, then I'm like kind of confined. I'm like kind of a decent person, right? But now let's consider another situation where my mom went for shopping. Okay, she's not there at this point in our house. So I say, Papa, please, pizza. And Papa is like, obviously, why are you requesting? I am ordering myself, right? So we feel more like, whoa, now we can do whatever we feel like, right? That means when we are under the influence of just one parent, we are like, whatever we want to do, we do, right? The same thing happens in the case of bond pairs and lone pairs. These two electrons, they are under the influence of nitrogen as well as hydrogen. So they are confined in this much area. Fine. Similarly, these two are confined in this much area. Similarly, these two are confined in less area. But you look at this pair of electron. This is like only under the influence of one parent atom, which is nitrogen. There is no other atom to keep a hold on these two pair of electrons. So they spread like anything, and they want to occupy more and more space. When they occupy more and more space, these lone pairs will repel the bond pairs. The lone pairs will repel the bond pairs. Obviously, the bond pairs and bond pair will also repel each other. But since they are confined in lesser area, so the repulsion between bond pair is kind of less compared to repulsion between lone pair and bond pair. Right? So can I say lone pair bond pair repulsion is greater than bond pair repulsion? Right? Because of which the two bond pairs, which earlier were to be at an angle of 109 degree 28 minutes, are now squeezed more close to each other. And when we squeeze them more close to each other like this, then the angle becomes 107 degrees. So this is also 107 degree. Okay? Remember, bond angle simply means angle between these two bonds. Bond angle doesn't mean angle between lone pair and bond pair, no. So although you might be thinking, ma'am, this angle will be greater than 109 degree 28 minutes, you are right. But this is not known as bond angle. Bond angle is the angle between two bonds. Done? So this is how we get an angle of 107 degree in case of ammonia. One last thing, let's talk about the shape. You remember, right, lone pair never comes in picture. You click a picture, you won't be able to see lone pair. So you will just be able to see something like this. And if I join these atoms, don't you think it's a kind of pyramid? Yes. So the shape is pyramidal. That's it. Done? So guys, this was the detailed discussion about the structure, shape, bond angle, hybridization in case of ammonia. I hope you understood this much. So just revise this. Next video, I'll be teaching you the concept related to water. Thank you. Bye-bye.